So in this case, we will find for the value of your VO using nodal analysis. Okay, find the value of VO. So how will we solve this one? So like typical nodal analysis equation, so first you would draw the datum or your ground. So this is the ground. Okay, after identifying your ground, so the second step is to find for your currents or the direction of your currents. After setting up this direction, you will use this direction in order to solve the currents in going and going out to your node. So we can find for your V1 and V2. Okay, so since there are no identified nodes yet, voltage nodes yet, so ang gagawin natin, mag-identify tayo ng nodes. So as you can see, there are two nodes that can be found in our circuit. We have our V1 and this is our V2. Okay. Take note that these nodes are already connected in series with this one. Therefore, we may not identify this as your V3. Okay. So we already have your V1 and your V2. Okay. So next is to identify the currents that will enter and going out your node. So take note that the assumption of direction will be the direction all throughout your calculation. So we have our 40 volts, so going up, so pupunta yan dyan, and then your V1 to V2. So I will assume that this will be my I10 from my 40 volts to my V1. Okay, so palitan natin yung kulay ng pen kasi masyadong pangit din yung sulat. So your I, let's say this will be my I1 2. Okay, and then my other current will be my I at 4 ohms and my current at I V2. Okay, so I will say that it will be your I20 volts to your V2, I20 to V2. Okay, take note that the numerals that I use are direction dependent. So take note that your I12 is equal to negative I21. Okay, so since they are direction dependent, therefore the assumption should be constant all throughout the calculation. So let's get the voltages or the currents entering to your V1. So at node V1, what are the currents entering to your node V1? So we have our I40 V1, I41. It is entering, so therefore it is positive. Plus our I12, it's going out the node, so it is negative, so I12. And then our 5 amperes, so it is going out the node, so it is negative 5 ampere. By conservation of charges, it is equal to 0. Okay, that is our equation for your node 1. Next is your equation at node 2. At node 2, we have our equations, which are basically your, so I12, it's going into the node, so it is positive, I12, and then your I4, it's going out the node, so it is negative I4 ohms. And then we have our I20 V2, it is positive because it is going into the node, I20 V2. Okay, so these are our currents. Okay, dapat is equal to, okay, there is also another current which is not identified yet, so it is your 5 ampere, it's going into your V2, so positive 5 ampere. It is equal to 0 via conservation of charges. Okay, so after defining the circuit, another thing, nakalimutan natin i-define yung mga values ng I natin. Okay, but it's not too late for that, so let us define it. So we have our I41, so lalakyan ko lang konti. Okay, so I41, 40 V1, okay, or I41 lang daw. Okay, from 40 volts to V1, so we have our current potential, from higher potential to lower potential. Take note, that is my assumption. So I have positive 40 minus my V1 divided by 1 ohm. And then I have my I12. I12 is that I have my V2 minus V1 all over our, okay, take note that our direction from V1 to V2. So I V1 minus V2 all over my 2 ohm. Okay. Next is our I4 ohm, which is basically equal to V2 all over 4, and our I at 20 to V2, which is basically equal to, so take note, negative yung nasa taas niya. So from our previous examples, so kung ano yung nasa taas, kasi we are passive yung ginagamit natin, no? Passive, basta passive theorem, o yung tinatawag nating passive flow of electricity. Okay, so since nasa taas yung negative 90 natin, this is from your higher potential to lower potential, so we will use the negative 20 volts, so instead of positive 20, kasi ito yung nasa taas, siya yung magsusupply. Okay, so negative 20 minus our P2 all over our 8 ohms. Okay, next is we will substitute the values of our I40, 1, negative I12, and 5 amperes. So we have our I41, so we have I41, we have 40 minus V1 over 1, and then we have our negative I12, which is basically equal to V1 minus V2 all over 2. So plus negative V1 minus V2 all over 2 minus 5 ampere equals 0. So para ma-check nyo kung ilan dapat yung mga value yan, kung ilan yung mga elements na nakakabit sa node na to, yun dapat yung bilang ng variables, ng mga variables mo. Basically, yung mga variables na kailangan mo compute para dyan sa node na yan. So we have our 40 minus P1. So for the further manipulation of this equation, we have 40 minus V1 plus negative V1 plus, so kasi negative times negative, di ba? So V2, so magdi-divide by 2 tayo, divided by 2, minus 5 equals 0. So you see that negative V1 minus V1 over 2, we have 40 minus 3 V1 all over 2 plus our V2 over 2 minus 5 equals 0. So by simplification, kahit hindi na tayo mag-multiply ng 2 dyan, kasi gagamitin naman natin yung calculator nyo mamaya. So 3 halves V1 plus V2 all over 2 plus positive 35 because negative 5 plus 40, okay, equals 0. So therefore this is equal to negative 3 halves V1 plus V2 all over all over 2 equals our 35, right? This will be our equation 1. Oy, wow, mali, no? Mali yung napindot. Yan. So yan, this will be our equation 1. Okay, so since we have already identified your equation 1, our next equation will be, okay, let's check your equation. So pag tinranspose natin yung negative 30, yung positive 35 yan, dapat magiging negative 2, right? Okay, next is that we will solve the equation at our node 2. Okay, what is our I12? So our I12 is equal to V1 minus V2. Since positive yan, wala na tayong papalitan. V1 minus V2 all over to 1 ohm. V1 minus V2 all over 2 ohms. Okay, 2 ohms for that, 2 ohms. Plus our I4. Okay, minus V2 all over 4 ohms. And then, syempre plus, kasi going into the node dyan, plus our negative 20 minus V2 all over 8 plus our 5 ampere equals 0 because of the conservation of our charges. So for the manipulation of this equation, we will have V1 over 2 minus V2 over 2 minus V2 all over 4 plus negative 20 all over 8 minus V2 all over 8 plus 5. Okay, so we have a value equal to V1 over 2. So V1 over 2 na talaga to kasi isa lang siya. Next is our V2 over 2. So we have mag-plus na muna ako. So negative 1/2 plus negative 1/4 plus our negative 1/8 multiplied by our V2 plus 5 minus 20 over 8. Okay, so calculator, by solving your negative 1/2 by your calculator, siguro may calculator kayo dyan, no? So plus minus 1/4 minus 1 over 8. So we have a value equal to negative 7 over 8 V2 multiplied by our V1 over 2. So plus 5 minus 20 over 8 is equal to 5 halves. Positive 5 halves. Okay, equals 0. So for the manipulation, we have V1 over 2 plus minus 7 over 8 V2 equals negative 5 halves. So as I have said, you may compute your formulas or your equation of variables by the different mathematical rules like substitution, cancellation, or pwede rin Cramer's rule. But since it can be calculated using your calculator, so let us solve it using your calculator. So we have negative mode 5 1 for those who have 991 ES. So we have negative 3 halves for your B1, and then 1/2 at your equation 1 and 35, and then we have 1/2 minus 7 over 8 is equal to negative 5 halves. Okay, so we have tabulated our equation. So we have negative 35. Okay, pakilagay na lang. Kung wala kayong calculator, okay, I will input it in your screen. Ako na mag-i-input para sa inyo, guys. Okay, so we have AC negative 3 halves. Negative 3 halves. Then we have our 1/2. And then negative 35. Next is that we have our 1/2. Positive 1/2. And then negative 7 over 8. And our negative 5 halves. Negative 5 halves. Negative 5 halves. So we have a value equal to your V1 equals 30 volts and V2 is equal to 20 volts. Okay, so V1 is equal to 30 volts and V2 is equal to 20 volts. Okay, these are our values. But what is our VO? Notice, guys, that your VO is in parallel with this V2. In fact, yan na mismo yung voltage ng V2 nyo. So therefore, I may say that my V2 is equal to VO. Therefore, our V2 is equal to VO, which is equal to 20 volts. This is our answer. Okay, so that is our another example for your case 1 nodal analysis. Bye.